this is a lecture in which we are dealing with only the area aspect, areas of triangles and polygons, more specifically in terms of quadrilaterals, which includes parallelograms, squares, rectangles and other four-sided figures. Of course, whatever can be done for triangles and quadrilaterals can be extended to polygons of any number of sides. The only thing is we'll have to probably break that polygon into regions which are consisting of triangles and quadrilaterals. Well, so we have a triangle with vertices 2, 1, 3, minus 2. The third vertex is unknown, but that vertex satisfies the equation y is equal to x plus 3. Area is declared as 5. What are the possible coordinates of the third vertex? Is it only one triangle which is possible or more than one? Take 2, 1, 3, minus 2, x comma x plus 3 and 2, 1 and compute the area. Area is half mod minus 4 minus 3 plus 3x plus 9 plus 2x plus x minus 2x minus 6, and this is given to be 5 units. Half mod minus 7 minus 6 is minus 13 plus 9, so that becomes, we'll write it clearly, 3x plus 2x 5x, 5x minus x is 4x is equal to 5. So this makes it mod 4x minus 4 is equal to 10. 4x minus 4 is plus or minus 10. 4x is 4 plus or minus 10. So x is equal to 14 by 4 or minus 6 by 4. That is, x is equal to 7 by 2 or minus 3 by 2. These are the possible x coordinates of the third vertex, and the y coordinate is x plus 3. So since y is equal to x plus 3, in case 1, when x is 7 by 2, y will be 7 by 2 plus 3, that will be 13 by 2. Case 2, when x is minus 3 by 2, y will be minus 3 by 2 plus 3. This will be nothing but 3 by 2. So the possible coordinates are 7 by 2, 13 by 2 and minus 3 by 2, 3 by 2. So you can see that options A and C are both possible in this problem. So 7 by 2, 13 by 2 and minus 3 by 2, 3 by 2. So this is a problem with two multiple choice questions, answers which are likely answers. This is a problem based on very simple mensuration properties and basic coordinate geometry. We have a rectangle, 3 of whose vertices are declared. Origin A0, 0B. So this is on the x-axis, this is on the y-axis. So you can easily see that we are in the first quadrant, right? If you assume A is positive and B is positive. So without much of difficulty, we can say the coordinates of B will be A comma B, right? So therefore, the whole problem has become extremely simple. Now let us start with perimeter is equal to 14. So perimeter is equal to 2 times L plus B. If you can take this as length and this as breadth, then it is 2 times A plus B is equal to 7. I mean, A plus B is equal to 7. Now, what else is given? Diagonal is equal to, right, this distance or that distance. So it is square root of A square plus B squared, and that is given to be 5. So A square plus B square is equal to 25. What is required? Area. Area is nothing but AB. We will have to calculate this quantity. Now, students normally take these two equations and solve for A and B and then calculate AB. But you know, when AB is required, sometimes individually calculating A and B may not be required. So let us see how it can be done. Now if you take A plus B whole squared, that will be 49. This is A squared plus B squared plus 2AB is equal to 49. So 2AB is equal to 49 minus 25, which is 24. So AB is 12. So I think this is basically a school level mathematics problem where you don't have to really bother, because an extremely simple situation has been given in this question. You can see that the correct option for this problem will be C. This is a problem based on the midpoint theorem and other things. So basically computing areas of quadrilaterals and triangles. But one useful information is M and N are both midpoints of those sides, right? So therefore we'll begin with an assumption that the side of the square is A units. So when you look at area of the square, it will be A squared. Now this will be useful in the first and the last bits, because area of square is visible in these two questions. Okay, now if you take that line, then you can easily compute what is the area of triangle MQN. Now this will be A by 2, right? This will be A by 2, this will be A by 2, and if you take area of triangle MQN, it is half A by 2 into A by 2. So this will be A square by 8. Now MQN is available here. Now we want other things like OMN, right? OMN. OMN is nothing but this triangle, and this may be slightly difficult to calculate, but you can find out these areas. This is already known to us. You can find out this area. These two will be similar. So if you look at OPM, it will be half into base into height. This is also A by 2. A into A by 2. So this is A square by 4. This will also be the area of triangle ORN. So now you can easily calculate this area. So area of OMN, and that will be nothing but the total area of the squared minus this area plus this area plus this area. So that is A square by 4 plus A square by 4 plus A square by 8. How much this comes to? A square minus, if you take 8 as the LCM, 2A square plus A square, 2A squared is 4A squared plus 1. So that becomes 5A squared. So this becomes 3A square by 8. Right? Now I think more or less all the calculations are done. We want MQN, MQN is there, OMN is there, OPM is there, right, and ORN is there. So everything is available. And area of quadrilateral OMQN. Now where is OMQN? OMQN is this one. So that is nothing but this area plus that area. So just add those two areas and then slowly start taking the ratios. You will find that all the statements are true. A is correct, B is correct, C is correct, and D is correct. So do the basic calculations and then keep on substituting. So all options are correct for this problem. This is a problem based on area of triangles. Now we are given a triangle whose area is 32, but the coordinates are in terms of some unknown parameters, m square, 2m, etc. Now he wants the condition that m and m dash should be satisfied for this to be true. So let us do it the usual way. M squared 2m, mm dash, m plus m dash, m dash squared, 2m dash, and then repeat m squared 2m. So half mod m cube plus m square m dash minus 2m square m dash plus 2m m dash squared minus m dash squared minus m dash cubed plus 2m dash squared minus 2m square m dash equal to 32. Right? So you know there are some similar terms. Don't forget the modulus because it leads to multiple answers. M cube. Let's look at this one. This and this are similar. So you will get minus m square m dash minus 2m square m dash makes it minus 3m square m dash. So this is accounted for, this is accounted for. Now let's come to this one. This and this are similar. So you'll get m dash squared plus this one, that makes it 3m m dash squared minus m dash cubed is equal to 32. Now students with good algebraic knowledge will find that this is a perfect cube. M minus m dash whole cube is equal to 32. 32 into 2 in fact. So mod m minus m dash is equal to 4. So m minus m dash is equal to plus or minus 4. So you can find that options A and B are both correct. So not much in this problem, but it's careful handling of the condition and good algebraic knowledge. Question number 5. This is a problem based on equilateral triangles. 3 vertices are declared. There are 2 unknown parameters A and B, but there's a very strong condition. Both A and B lie between 0 and 1. That means they are basically positive, but they lie between 0 and 1. The question is, what is the estimate of the area of the triangle? So first, because the triangle is equilateral, the distances will be equal. So a minus 1 whole squared plus 1 minus b whole squared, that is square of this distance, is equal to 1 plus b squared is equal to a square plus 1. This is when you equate the squares of the distances. If you take these two first, you will get a square is equal to b squared, mod a is equal to mod b, and because he has said both a and b lie between 0 and 1, you don't have to take the negatives. So you get a very simple condition, a is equal to b. That is one thing. So now let us take this pair. Because b is already equal to a, this becomes a minus 1 whole squared plus 1 minus a whole squared, that is 2 times a minus 1 whole squared is equal to 1 plus a squared. So this will be 2 times a square minus 2a plus 1 is equal to 1 plus a squared. 2a square minus a square is a square minus 4a plus 1 is equal to 0. So let us compute the possible values of a. A is 4 plus or minus square root of 16 minus 4 by 2. This will be 4 plus or minus square root of 12, which is 2 root 3 divided by 2, which is plus or minus, 2 plus or minus root 3. Now you will have to reject a is equal to 2 plus root 3 because this is greater than 1. and our requirement is that a should be less than 1. So therefore, you accept a is equal to 2 minus root 3. Now what we need is area. Area of an equilateral triangle is root 3 by 4 a squared. So this is nothing but root 3 by 4 into 2 minus root 3 whole squared. If you simplify this, you will get root 3 by 4, 4 plus 3 is 7, minus 4 root 3. So if you take the root 3 inside, you will get 7 root 3 minus 12. So this is the unique answer to this problem. And you can see that option B for this problem will be correct. So unless you are very cautious, there is a risk that you may calculate with 2 plus root 3 also, and that option is also available in the question. So therefore you must be very cautious. This has got a unique answer. If the restrictions on A and B are removed, several options can become correct. Question number 6, another problem on areas. We got a triangle, no basic conditions on the triangle. Two vertices are origin and a comma 0. We got an unknown third vertex, but the area is declared. And then we got some options. What are the possible coordinates for the vertex, the third vertex? So 0 0, a 0, xy 0 0. So area is equal to half mod, only this will be activated, ay is equal to a squared. So mod ay is equal to 2a squared, and you can basically see options A and B which are given to you. Both satisfy this condition. Okay. The only thing is the coordinate x does not figure in this equation, but on the basis of the coordinate of y you can decide what the options can be. So please observe both A and B will be satisfying this condition. So two options are correct for this question. Question number 7, we got a triangle, all the vertices declared, delta is the area, then what's the value of 12 times that area? So this is a very elementary question, but can be useful for startups. So we can activate only this block. So delta is equal to half mod 125 by 6. So delta is equal to 125 by 12. Therefore 12 delta will be straight away 125. You can see option C is correct for this problem. Question number 8, we have got 3 points which are collinear. There are unknown parameters a and b, but there is another information, alpha and beta are the arithmetic and geometric means between a and b. This is given. So a and b of course should be positive. What could be the estimate of 4 alpha minus beta squared? So because the points are collinear, area will be 0. So let's compute that. A1, 1b, a minus 1, b minus 1, and a1. So mod ab minus 1 plus b minus 1 minus ab plus b plus a minus 1 minus ab plus 1, ab plus a. This is 0 because of collinearity. Now if you look at the situation here, this goes off. So you'll have 2a plus 2b, then ab minus 1, then b minus 1 minus ab plus b, a minus 1 minus ab plus a, and that's equal to 0. So let's look at the possibilities. So 2a plus 2b, and then we'll have minus 3 and also a minus ab is equal to 0. So this is 2 times a plus b minus ab is equal to 3, one of the cases. But a plus b is equal to 2 alpha. So 2 into 2 alpha, ab will be beta squared. So you'll get 4 alpha minus beta square is equal to 3. And you can find that option C is correct for this problem. So it's a straightforward situation where you must know the collinearity rule. Of course, you can also come through slopes, but anyway, getting this equation is very, very critical. And then use this arithmetic mean, geometric mean knowledge and then calculate the answer. So C is the correct answer. This is a problem based on quadrilaterals, not that very difficult. Now these are the generalized coordinates for vertices AN and BN. Now look at the sequence A1, B1, BN, AN. So if you look at A1, B1, BN, AN, for n is equal to 1, you will get 1 comma, I think this is n square 2n, so this will be 1 comma 2. B1 will be 1 comma minus 2. Bn you can copy that, n square minus 2n. An you can copy this, n square 2n, and repeat A1 again, 1 comma 2. So let's calculate the area. Half mod minus 2 is minus 4 plus minus 2n plus 2n squared plus 2n cube plus 2n cube, that is 4n cube, 2n square minus 2n. So let's look at this calculation. Half 4n cube minus 2n square minus 2n square, or rather plus 2n square is plus 4n squared. Then minus 2n is minus 4n, then minus 4. So if you take 4 out, this will be 2 times mod n square into n plus 1 minus 1 into n plus 1. So this will be 2 times n plus 1 into n square minus 1. This will be 2 times n plus 1 into n minus 1. So that becomes n plus 1 whole square into n minus 1. So you can pick up and see option D will be correct for this problem. So it's straightforward calculation. All may be useful for practice. This is a problem based on area of a triangle under the match concept. So for different p values, what are the corresponding delta values, where delta is area? So we'll first find out the generalized area and then do the matching. So let's write down the usual way. So delta is equal to half mod 3p plus 3 minus 2p minus 1 plus 4p square plus 2p minus 6p minus 6 plus 2p plus 2 minus 2p square minus 2p. Right, let's look for possible cancellations. Plus 2p minus 2p is going away. Minus 2p plus 2p is going away. And let's accumulate the rest. Half mod 4p squared 3p minus 6p. In fact, 4p square minus 2p square can be reduced to 2p squared. 3p minus 6p will make it minus 3p. 3 minus 1, 2. 2 minus 6 is minus 4. Minus 4 plus 2 is minus 2. This is what we have. So now, let us look at the first option with p is equal to 0. With p 0, these two will go away. Half into mod of minus 2, that is 2 by 2 is equal to 1. So, A is mapped onto S. Right? With p is equal to 1, 2 minus 2 will get cancelled and we'll get 3 by 2. So, 3 by 2 appears. So, this corresponds to. Let's try p is equal to 3 now. With p is equal to 3, this is 9 into 2, 18. 18 minus 9 is 9. 9 minus 2 is 7. So, we get 7 by 2 which appears in p. So, therefore, this goes to p. And then with minus 3, this is again 9 into 2, 18. But this becomes plus 6. 18 plus 6 is 24. 24 minus 2 is 22. So, with p is equal to minus 3, this becomes 18 plus 6 minus 2. So, 22 by 2 should become 11 by 2. So, possibly this option will be 11 by 2. So, it can be mapped onto that. So, that could be an error in the options. So, just find out the general triangle area in terms of p and then keep on replacing p with the different values. This is a problem based on logical reasoning. Statement number 1 says we got a triangle ABC, vertices declared as 2, 2, 6, minus 1, 7, 3. D, E and F are the midpoints of BC, CA and AB. And the area of triangle DEF is 19 by 8. Now that we'll have to verify by actual calculation. Statement 2 says lines joining the midpoints of the sides of a triangle. Now DEF are the midpoints. The lines joining the midpoints will segment the triangle into 4 parts. And theoretically, we can prove that all the 4 triangles are equal in area. So statement 2 is true. It's a universal truth as far as Euclidean geometry is concerned about triangles. So the only verification we have to do is about the area of triangle DEF, whether it's 19 by 8 or not. Let's compute the coordinates of D, which is the midpoint of B and C. So 13 by 2, comma 1. This will be 9 by 2, 5 by 2, and F will be 4, half. So we have 13 by 2, 1, which is D, 9 by 2, 5 by 2, 4, 1 by 2, and 13 by 2, 1. So let's calculate area of triangle DEF. Half mod. This is 65 by 4 minus 9 by 2 plus 9 by 4 minus 20 by 2 is 10 plus 4 minus 13 by 4. Half mod. 65 plus 9 is 74. 74 minus 13 is 61. 61 by 4, because 65 plus 9 is 74. 74 minus 13 is 61. Then we have minus 9 by 2 minus 6. So let us take 4 as the LCM, and you will get 1 by 8 mod 61 minus 18 minus 24. So therefore, you will have to calculate 61 minus 42. So this will be 19 by 8. So that tallies with the statement. So statement 1 is true, statement 2 is also true, and 2 is justifying 1 because 2 is a universal truth. Statement 2 is universal truth. Therefore, option A for this problem will be correct. So these are some problems basically on areas of triangles and polygons based on different types of testing methods. So at the base, you must be able to compute the areas correctly. In case parameters are involved, study the conditions carefully and then identify which one should be rejected and which one should be accepted.